Appreciate the opportunity to be here today and talk about the past, present, and future of renewable energy in Texas. Next slide. A little background on the North Texas Renewable Energy Group, or NTREG as we call it. We are the North Texas chapter of the Texas Solar Energy Society, which is the state chapter of the American Solar Energy Society, which has been around since 1954, advocating and informing and educating people about solar energy. Next slide. Let's start with the basics. Next slide. The Texas grid is a standalone grid known as ERCOT, the Electricity Reliability Council of Texas. It's not part of the Eastern Interconnection Grid or the Western Interconnection Grid. And some of you may be wondering why Texas is its own interconnection grid when people know that the larger a grid is, the more resilient and the more stable and just better the grid is. Well, the answer is the Texas legislature did not want federal oversight of the Texas grid. So the entire ERCOT interconnection is within the state boundary of Texas. And since it doesn't go outside of the state, there is no federal oversight required. Y'all can determine if you think it's a good idea that we're not connected to the other grids, especially with what happened this past winter when the grid failed. And unfortunately, the Texas legislature did not do too much to improve the grid oversight in this latest session. Next slide. The projected population growth in Texas between 2010 and 2015 is significant. The dashed line is with the assumption of zero in-migration, which is, of course, absurd. So we really need to look at the two solid lines and realize that there's going to be a lot more people in Texas in the coming years. Next slide. The good news is Texas has more solar energy potential than any other state. The darker the color, the higher the solar irradiation is for a given area. So obviously, Texas west of the Pecos has the best solar potential per square meter, but all of Texas has very good solar potential, and it's a large state, so that's why we have more solar energy potential than any other state. Next slide, please. In fact, the solar energy hitting Texas, just the boundary within Texas, within a month exceeds all of the oil and gas ever pumped out of Texas in the way of energy. So when you think about the oil and gas that's been pumped out of this state, it is an insignificant portion of what hits the state, the sunshine that hits the state within a 30-day period. Next slide, please. This is a map of the wind speeds in different areas of the United States. The darker the color, the better the wind speed is and the better the wind potential is. Obviously, the area between North Dakota and Texas has the greatest wind potential in the state, and that's also where you have the greatest amount of wind energy in those states. And some states like Iowa and Kansas get significant portions of their energy or their electricity from wind power. Next slide. So the Texas population is growing rapidly. Some of the fastest growing cities in the U.S. are in Texas. A larger population means more water will be needed and more energy will be needed. But needing both more water and more energy can be a major problem because of the fact that with the warming planet, Texas is getting hotter and it's getting drier. Next slide, please. So how much water is used by different types of power plants? Well, coal can potentially be the biggest use of water at up to 1,100 gallons per megawatt hour produced. Nuclear second, 600 to 800 gallons per megawatt hour. Natural gas is 20 to 300. Solar and wind use zero water. So when we're in a situation of the average Texas family using around 250 gallons of water per day, and those families are increasing, and the amount or availability of clean water is going to be stressed because of an increasingly hot and arid environment. Well, where will the water come from for all those families to use and to frack for natural gas and to run the power plants? And by the way, hydraulic fracking can use over 1 million gallons of water for each well drilled. The reality is we can't do it all. It's not going to happen. So we either need to have extreme water conservation measures in the state so that we can keep using water to produce electricity from coal and nuclear natural gas plants, or we have to shift to renewable energy. Texas could save billions of gallons of water every year by switching entirely to renewable energy. Next slide, please. The other low-hanging fruit, as we can call it, is by improving efficiency. Texas currently ranks 25th. They may change a little bit in the last couple of years, but we're in the middle of the pack. And if we were as efficient as California or Massachusetts, we wouldn't need as much energy. We wouldn't need nearly as much energy as we do right now. So obviously, we have got to learn how to become much more energy efficient than we currently are. Next slide, please. So how much energy is actually produced per the energy input? And if you look at this chart, it's very telling. Coal is the worst. Only 29% of the energy that's contained within coal is actually ends up as electricity at the end of the process. Oil is only slightly better at 31%. Natural gas at 38%. You go up to solar, nuclear, hydro, geothermal. Wind is by far the most efficient at turning the kinetic energy of wind into electricity. Those turbines out there are extremely efficient, and they're getting more efficient all the time. Next slide, please. Okay, let's go into the past a little bit about renewable energy in the state. Next slide, please. This is a slide showing the solar energy leaders in 2013. And they're also highlighted in yellow on the map. And as you can see, Texas isn't even on this map. And there's very small states that don't have as much solar radiation, like New Jersey and Massachusetts on this map, and yet Texas isn't. And so the obvious question is, why weren't we, and what could we have done about this? Next slide, please. And the other situation is where we were with our wind generation. And as you can see, from 2000, when there was 116 megawatts of installed wind energy, which is not even a large wind farm by today's standards. That's just basically nothing. And the growth in wind energy has been truly phenomenal, where we are now in 2021, we're up over 30,000 megawatts of installed wind generation in the state. That's been a true success story. But as you can see from the previous slide, wind turbines are phenomenally efficient at converting wind itself, the kinetic power of wind, into electricity with no water required. Next slide, please. Again, this is where the wind turbine capacity by state was at the end of last year. You can see at that point we were up to 33,000 megawatts, and obviously we dwarf every other state. And if Texas was a standalone country, we would be fifth in the world in wind generation just by itself, Texas by itself. Next slide, please. So the ERCOT fuel mix for the past 15 years is very telling. Go back to just 2006, 97% of all energy was produced by natural gas, coal, and nuclear. Only 2% was wind. And so if you roll that forward to 2020, just 15 years later, natural gas is still about 46% of the fuel mixture, but coal has declined from 37% down to 18%. Conversely, wind has increased from 2% up to 23%, and nuclear has subsided from 14% to 11%, and now solar is starting to show up as a percent in this chart for 2020. It's only 2%, but it is going to grow very rapidly. Next slide, please. Okay, let's talk about the present. Next slide, please. Which energy source looks like the best and cheapest energy source for the future? And this is just a historical trend line from 2009 to 2019. As you can see, coal was basically flat. They were at $111 per megawatt. In 2009, they dropped to $109 per megawatt hour. Then wind dropped from $135 per megawatt hour down to 40. And you can see a huge drop off between 2009 and 2011. And after that, it's more of a gradual decline, but it's still going down. And as you will see in a later chart, it's projected to go down quite a bit further as time goes by. Natural gas in this chart did also decline from $83 a megawatt hour to $56 a megawatt hour as coal plants became more efficient. But the big drop was utility scale solar that went from $359 per megawatt hour. And that tells you right there, solar back as recently as 2009 really wasn't competitive with other energy sources. But look at the drop off between 2009 and 2011. It went from $359 to a little over $140, $150 per megawatt hour, and now it's down to 41. So it's gone way down. I'm sorry, down to $40. It's gone way down, where it's now the cheapest source of electricity And since 2019, wind and solar have continued to decline, and they're far and away the cheapest energy sources at this point. Next slide, please. So what is the renewable energy potential for Texas? And this chart is very good for showing the renewable energy potential for all states. And as you can see, more than 1,000% of our energy requirements could be met by renewables in Texas. And if you look up through the Dakotas, Montana down to New Mexico, and Louisiana up to Minnesota, that entire area could be easily met with just renewable energy, with just wind and solar. So the potential's there. We just have to capture that potential. Next slide, please. So this chart of the U.S. wind and solar leaders by state, you look at the top, and Iowa's the top, is all wind. There's no solar. Oklahoma, Kansas, Illinois, Colorado, they're primarily wind or exclusively wind energy. And of course, you look and you think, well, where's Texas? Texas is down at the bottom. Texas and California are so large compared to the rest of the states that they had to move them down and have a different chart for them. You can see Texas is primarily wind, but we're talking 142,000 gigawatt hours of electricity produced by renewables compared to 61,000 for California, which is primarily solar. But you can kind of see the states that have more solar potential than wind and vice versa. North Carolina, Arizona, huge solar potential, not so much wind. And so they get most of their renewable energy from solar. So does Georgia, Massachusetts, and New Jersey do it also, but they also had very effective state policies for promoting the growth of solar energy in those states. Next slide, please. So the average retail price of electricity in Texas from 2002 to 2018, you can see it kind of bumped up in 2004 to 2010, and then it's just hovered between 7.5 cents and 10 cents a kilowatt hour. It'll be interesting to see what happens when some other solar retailers like Tesla get into the market, because with coal still being a big chunk of it and natural gas being a big chunk of our electricity generation in Texas, it's going to be hard for that line to move down. But as solar and wind take over a greater share of electricity production and they become ever cheaper, that should put some downward pressure on that line. If it doesn't, then I think there may be something else going on with the utility companies that we're unaware of, that they're just not letting it decrease below that general area there. Next slide, please. So again, this is the cost decline for different types of solar photovoltaic systems. Residential has always been more expensive to put in place than commercial or utility scale, either fixed or one-axis tracker. You can see the dollar amount for installed solar for utility scale is significantly lower than residential. And the question is, why is it so much cheaper when the solar panels themselves and the inverters and all the equipment are basically the same cost? The reality is that it's the soft cost, the permitting fees, the marketing fees, and all the rest of that that prevents residential solar from becoming as cheap as utility scale solar. Obviously, if there was a statewide or nationwide solar permitting process that was easy and quick, then that would go a long way toward reducing the cost of residential solar and to some extent commercial rooftop, because you have the same soft cost with respect to permitting and whatnot. And it would actually help utility scale systems as well, but it would have the biggest impact on residential and then solar. Next slide, please. So what have the wind and solar power purchase agreement price trends been since 2002 to 2018? Well, you can see from this scattershot diagram and the trend lines, wind is going down steadily, but the solar prices are just in free fall, and they went from 2010 being more expensive than wind by a considerable amount to by 2019, solar is cheaper than wind for the power purchase agreements. Well, the power purchase agreements are the big industrial scale solar farms, and the way that the solar farms get built is those companies will sign a power purchase agreement, which is a long-term power purchase agreement with a big user, Facebook or Amazon or Apple or whomever, and they will agree to buy the electricity generated by that solar farm or that wind farm for a fixed period of time. It might be 10 years or 20 years or 25 years, and at a fixed price. Well, the fact that the power purchase agreement prices have continued to fall for both wind and solar is a good sign that we, as individual consumers, will hopefully be able to pay less for wind and solar energy as time goes by, because the more solar and wind is installed, the cheaper it becomes in the future to install more wind and solar also. Next slide, please. So this chart is what they call small solar leaders, and this is, when they say small scale, they're talking residential or small commercial type of installations, not those industrial solar farms. It's not surprising that California leads the way by a large amount. But what's interesting with this chart is the fact that New Jersey and New York and Massachusetts, which are not states with a lot of solar radiation and consequently not a lot of solar energy potential, are 2, 3, and 4 on this chart. And so the question is, why are those little states up in the Northeast above Texas, which is 6th on this list? Well, again, it gets down to state policies. The state policies in those states are very welcoming to solar installations, and so it makes it easier for people to install solar on their roofs. And so that's obviously a significant amount of generation capacity in those states, but Texas could easily be much closer to California. We could theoretically pass California if we had the right state policies in place. Next slide, please. So this is the top solar states overall for 2020. And as you can see, Texas is right behind California. And if you remember the slide from the past of renewable energy in Texas, in 2013, Texas wasn't even in the top 10. So we went from being outside of the top 10 states to now we're number 2. And we've passed up all those other states, including the small states like Massachusetts and New Jersey, that probably never should have been in front of Texas to begin with. Next slide, please. Now, if you look at this trend line, Texas moved from very, very small amounts of installed utility scale solar capacity in 2015 to being second to California. And if you look at the trend lines, Texas has a lot steeper trend line going up than California. And right now there is about 91,000 megawatts of installed or planned utility scale solar for Texas. If we can install that amount of utility scale solar in the next year or two, we pass California. And then we would be the number 1 state in solar generating capacity and wind generating capacity. We already are in wind. We're way above everyone else in wind, but that would put us also ahead of any other state for solar as well. So at that point, we'd be in our rightful spot as the number 1 state. Next slide, please. This chart shows the wind turbines installed in the U.S. And as you can see, there's a lot of wind turbines all over Texas, including down in the Rio Grande Valley of Texas. But most of them are in that West Texas area where you remember the map of the United States showing the wind speeds. That's where a lot of the high winds are in Texas. That being said, down the Rio Grande Valley, especially near the coast, yeah, there's a lot of wind speed down there and a lot of wind energy potential that's obviously being taken care of and utilized down in that area. Next slide, please. Now, this particular slide shows what the effective mile per gallon rate is in different areas based on the energy mix of our grid if you're talking about an electric vehicle. So in ERCOT, we are effectively 60 miles per gallon based on the amount of wind, solar, coal, natural gas energy production in the state. 60 isn't bad. We're better than some of the areas in Florida and the Southeast. But then you look at California and they're at 109, or you look at New York and they're at 191. So there is a lot of room for improvement, even for Texas. And as we get more, again, wind and solar energy connected to the grid in this state, and we decommission more coal plants, our miles per gallon average will increase. Next slide, please. This chart shows the decline in coal over just 5 years. And as you can see, Texas was way above every other state in the amount of coal that we used. And even after the decommissioning of all the coal plants in Texas, we are still above any other state, even where they were in 2015. So we do have our work cut out for us, and we really need to get as much renewable energy connected to the grid so we can finish decommissioning the rest of the coal plants in the state and get down where we need to be, which is no coal plants operating in the state. The fact that we're still way above every other state kind of speaks to our mid-range of energy efficiency or lack thereof, and the fact that we just started from such a huge number. Texas used so much more energy than any other state, and we still do, that it's just going to take longer to finally shut down the coal and then the natural gas plants. But we really need to start with the coal plants first because they are the worst polluters of all. And the electricity generated by coal plants is the most expensive electricity on the ERCOT grid. So if we want cheaper electricity, we've got to work on getting these coal plants shut down. Next slide, please. So this is the installed and estimated cumulative ERCOT solar and wind capacity. And you can see that we went from basically all wind in 2014, and we were about 12,000 megawatts. And wind increase, solar started to show up in 2017, 2018. If you look at 2022, 2023, solar is now going up exponentially. And wind is still increasing, although it's not increasing as fast as it may have previously in the past. But that's being more than offset by the new solar capacity that's coming online. And again, after 2023, there's huge amounts of solar that are in the planning or at least discussions with financiers about getting the projects off the ground. And eventually, solar is going to hopefully catch up with wind in the future. And between wind and solar, they would then be a very, very large percent of the solar capacity in this state. Next slide, please. So this is the total renewable energy generation by state as of 2019. Again, wind for Texas is by far the biggest chunk of the renewable energy generated in Texas. California is about even between solar and hydroelectric with a little wind in there. Unfortunately, Texas doesn't have much hydroelectric potential, so we really have to just use solar and wind to increase our renewable electricity generation. Again, Washington State is primarily hydro, but being way up in the Northeast, they do not have as much wind or solar potential as Texas does, so they're using what they have. And it won't be too many more years till Texas passes California, and then we will be the top renewable energy state in the country. Next slide, please. So this is our ever-changing energy source by state. It's very easy to look at this chart and see the direction that different energy sources are going. Coal is obviously collapsing. Almost the entire column of all the states in coal is red, which means that the amount of coal generation in all those states is going down. And Texas, again, was close to the top of that at 42,700 megawatts being shut down and decommissioned. And but all the other states are doing a similar type thing. Natural gas, it's a mixed bag. There are some states that are reducing their natural gas energy production or generation. Texas is not. Texas added quite a bit. Virginia added a lot. But the fact that some states are decommissioning their natural gas plants and they're reducing their natural gas electricity generation is very telling. They're getting ahead of the curve. They're already deciding that they have got to go almost exclusively with renewable energy, wind and solar, to help their grid, but also to do what they can to address climate change. Hydro, kind of static. Wind and solar, if you look at those two columns, they're almost entirely black. It means the generation of both wind and solar is increasing across the board in pretty much every single state. Again, if you look at Texas, we've got some of the biggest numbers there, and especially wind. So we will hold our top spot in wind energy generation, and it's just a matter of time before we will be the top spot for solar electricity generation as well. Next slide, please. So where do the federal energy incentives go? And this chart is pretty easy to understand. Almost 2/3 of the federal energy incentives go to fossil fuels. Small amount goes to wind. 12% goes to other renewables. That's solar, that's biomass, that's hydro, that's everything. And then nuclear gets 21% of all federal energy incentives. The obvious question is, why does solar and why does nuclear get so much of the federal energy incentives? And the reality is those industries give campaign contributions. You can call that a different term if you want, but it's campaign contributions to the right political leaders, and they get their money returned in a big way. And it's, I'm sure those campaign contributions have an extremely good ROI for the fossil fuel industry and the nuclear industry, even though those industries both will have to be phased out over the coming years or decade. Next slide, please. So what's happened to the value of the major oil and gas companies? And when I say major, there's basically 5: ExxonMobil, Chevron, Shell, Total, and British Petroleum. As recently as the first quarter of 2018, they were worth $1,200 billion, which is $1.2 trillion. Since then, they've experienced significant declines in their market value, such that now they're collectively worth something around 600 billion. 600 billion is still a lot of money, but it's half of $1.2 trillion. So that is just a phenomenal decline in value. especially when you consider that we've got individuals in this country, a couple of individuals that collectively uh, have as much wealth as the top 5 oil majors do now, which is an incredible turn of events for those companies in a very short period of time. And the downward pressure on those market values is going to increase as we get more EVs on the road, electric vehicles or EVs. It's going to have a downward pressure on gasoline and diesel sales, which is the lifeblood of those oil and gas super majors. And so their market capitalization value is going to have some serious pressure on it in a downward way, continuing on for the foreseeable future. Next slide, please. Okay, let's talk about the future of renewable energy in Texas. Okay, so this is a chart showing the logarithmic decline in the dollar amount per kilowatt of installed solar. And so the amount that it cost to install solar back as recently as 2010 was obviously cost prohibitive. That's why in that chart, solar was so costly to install and develop vis-a-vis the other energy sources. But if you look at the decline in solar prices between 2010 and 2020, and then you look at the projected decline between 2020 and 2030, that will clearly make solar much cheaper than any fossil fuel source. It already is, but at that point, the cost differential is going to be extreme between solar and all fossil fuel sources of electricity. Next slide, please. And an important item for renewable energy is battery storage. And the cost of battery storage is following a very similar logarithmic decline that solar did. And so between 2010 and 2020, you basically went from $1,000 per kilowatt hour down to about 100. And if you look at the trend line between 2020 and 2030, the cost will continue to decline. And by 2030, we're looking at maybe $30 or $40 per kilowatt hour for battery storage, which makes it extremely cost competitive to then build a lot of battery storage to back up the solar and wind that's being produced. Next slide, please. So this is the vision for transitioning to 100% renewable energy in Texas. If you look to the right, kind of, pardon, over at the lower side on the right, you've got wave and geothermal and hydroelectric and tidal turbines, which collectively are not even going to be 1% of the total. So really, we have to be focused on residential rooftop solar, which will be about 3%. And this is if we can get to 100% renewable energy by 2050. Solar plants will be close to 16%. Concentrating solar, which is using mirrors to concentrate the sun to heat either water or some kind of medium like oil to then heat water, will be 14%. Onshore wind will be 50%, and offshore wind will be about 14%. Interesting thing about offshore wind is right now in the United States, there are eight offshore wind turbines. Europe has over 5,400. So they're obviously way ahead of us. And for anyone that spent time on the beach in Texas, it's pretty apparent there's plenty of wind offshore. And we really need to utilize that because it's a very strong, consistent wind. And that needs to be a significant part of our energy mix, along with onshore wind. Next slide, please. This chart shows the cumulative energy-related carbon emissions from 2015 to 2050. Obviously, if we follow that upper tan line, it will be an unmitigated disaster for humanity and for the planet. We simply cannot go down that road. It's not going to be a viable option. So we have got to lower that line. And ideally, we would lower to that kind of crosshatched area or range down at the bottom. And that's why we've got to do everything we can to make sure that line stays as low as we possibly can. Because again, on that tan line, we will hit some very dangerous, some very, very negative feedback loops, or releasing methane in the Arctic and causing problems like that. And Texas will not do well in that environment. It will be so hot and so arid in Texas that I don't know if it will even be fit for human habitation at that point. Next slide, please. Okay, so in addition to getting more energy from renewables, we also need to move to electric vehicles, or EVs. EVs are very quiet. If you stood next to one that's on, you can't tell it's on, and it rolls past you, and all you hear is the tire noise on the street. You don't hear anything from the car itself. They're extremely quick and responsive. They are much, much more fuel efficient than an internal combustion engine, otherwise known as an ICE vehicle. They're smooth and fun to drive. They're much cheaper to maintain. We're talking about 20 moving parts plus or minus in an EV versus 2,000 plus or minus in an ICE car, which results in annual maintenance savings of about $500 per car. There's no air filter, oil filter, spark plugs, radiator fluid, transmission fluid, all that does not needed in an EV. Next slide, please. So the overall energy efficiency of an EV versus internal combustion engine is about 5 to 6 times as efficient. An EV is as efficient as an internal combustion engine car. So keep that in mind. We'll go to the next slide, please. Most U.S. households have at least one car, and most have two. Each car is typically driven over 10,000 miles per year at about 22 miles per gallon. At an average of 22 miles per gallon and 10,000 miles per year per car, the average American household uses about 909 gallons of gas per year. If the internal combustion cars or vehicles were just as energy efficient as an EV, they would get about 117 miles per gallon. At 117 miles per gallon, the number of gallons consumed by the typical household per year would drop from 909 to 171, and annual gasoline expenditures would decrease from $1,929 down to $363. Right there, you can see the benefit of having a much more efficient EV. Next slide, please. Then when you take the fueling cost of the cars, and you take the average number of miles per month, which is about 1670 based on the 20,000 per year. This is per household. And an average miles per gallon of 22, ICE vehicles will burn about 76 gallons per month at an average cost of $2.50 a gallon. It'd take about $190 a month for gasoline. EVs use about 30 kilowatt hours per 100 miles, or about 501 kilowatt hours to drive 1,670 miles. An average cost of 11.9 cents per kilowatt hour, it costs about $60 a month in electricity to keep an electric vehicle fueled up. Next slide, please. So again, for anyone that's interested in additional information on the North Texas Renewable Energy Group, we can be located at www.ntreg.org, or you can learn more about the Texas Solar Energy Society at that address there. Solar United Neighbors is a great organization. They can be located there. And finally, to learn more about the DFW Solar Tour, which is coming up a week from this coming Saturday. It's coming up on October 2nd. It's very, very close. You can go to www.dfwsolartour.org. It will be virtual this year, so there won't be any type of super spreader event for COVID, and you can follow along from the comfort of your own home. With that, I'm through with the presentation. I appreciate the opportunity to make this presentation today, and I'll be happy to take any questions people may have for the last few minutes of our time here.
Thank you, Mark, so much. I love your presentation. I love that you presented so many sustainable solutions, because that's what we're all about here at Dallas College. And we do have a couple of questions. The first one is, are there any fossil fuel companies planning to take advantage of the tremendous growth potential in renewable energy? Looks like there's a tremendous profit potential there for companies that are forward looking.
Yes, and that's a great question, and you're absolutely right, Georgianne. Some companies like British Petroleum and Shell, the European oil majors, have started to invest more money in renewable sources, renewable energy. And I'm just talking right now at the old majors. I mean, obviously, some of the smaller companies are doing a lot also. But as far as the majors go, it's really the European countries that are pivoting away from fossil fuels toward renewable energy. I would say probably, unfortunately, the biggest outlier is ExxonMobil. They are not doing much to pivot from fossil fuels to renewable energy. Of course, ultimately they will pay the price for not getting on the bandwagon early, like those other companies are doing, and it will affect their stock price and will affect their bottom line in the future. But they're not going to listen to me, so they're going to have to just deal with it when it arrives.
Okay, thank you. Here's another one. If I heard you correctly, you said that fossil fuel companies get 66% of the federal incentives for producing a product that's devastating to our environment, to our health, and ultimately to our economy. So is there anything that we can do to stop that? I mean, I know writing our legislators is one thing, but I'm wondering if there's any proposed legislation out there that would help with this situation.
If there is proposed legislation out there that might help with this, I'm unaware of it. And
actually, I was thinking of the Citizens Climate Lobby legislation.
Oh, okay. Well, they help, but I think there's a basic disparity between the amount of money fossil fuel companies have to spend to bribe, excuse me, I should say, provide campaign contributions to legislatures at both the state and the federal level. And it's a system that, unfortunately, because of the ruling in Citizens United back in 2010, made it much easier for these companies to just throw money at political parties and at legislatures and do it in a way that can't be traced. They can do it through these dark money groups, which is absurd. It is totally absurd that they're allowing people to influence our democracy in such a way without the average person being able to even be aware of who's doing it and how much they're paying and what they want to get for all that investment they're making. It's just nuts that they've allowed that to be done through those dark money groups. I don't know how you change it because there's so much money tied up in the status quo and keeping that system in place because it benefits the large corporations and it benefits the extremely wealthy people. I would say for all the rest of us, we have to vote and we have to be engaged and we have to be passionate and we have to try and make a difference by voting the right people into office that will do something about this and address this underlying problem that will not be addressed with the current composition in the state legislature and the national legislature.
Thank you. Thank you so